In this video, we are going to talk about what an equivalent ratio is, how we find them, and where they might be useful in real life. Before we can get into what an equivalent ratio is, we have to define what a ratio is. A ratio compares two or more numbers and can be written in three different ways. It can be written in words, with a colon, which is the two dots, or as a fraction. So in the picture below, we have some triangles and a square. And if I wanted to write the ratio of squares to triangles, I could write it as 1 to 3 in words, 1 to 3 with a colon, or 1 to 3 as a fraction. I want to point out where those numbers come from. Since I want the ratio of squares to triangles, the 1 is for the number of squares in the picture, and the 3 is for the number of triangles in the picture. Now, what's really important about writing the ratios is that order matters. It would be different if we asked for the ratio of triangles to squares. If we were to ask for that, we would have to put the number for triangles first. So I'd have to put 3 first, then the number for squares. So the ratio of triangles to squares is 3 to 1. Now we can kind of start talking about equivalent ratios and how we find them. So equivalent ratios have the same value. They are essentially equivalent fractions, so they have the same simplest form. If you look at the picture below, we have 3 different sets of pictures, all of triangles and hearts. So in the first one, we have 2 stars and 1 heart, leaving our ratio to be 2 to 1. In the second, we have 4 stars, 2 hearts, leaving it to be 4 to 2. And in the final, we have 6 stars and 3 hearts, leaving it to be 6 to 3. Those are all equivalent ratios, and it's for this reason that we're going to talk about below. If we were to look at these examples below, the 3 to 4, we can make that an equivalent ratio by multiplying by 5 on both sides. This times 5 and this times 5. As long as you are multiplying or dividing by the same number on both sides, you will generate an equivalent ratio. Similarly with this example, 12 to 8, if you were to divide by 2 on both sides, you're going to get an equivalent ratio of 6 to 4. So the reason that picture at the top is equivalent, to turn a 2 to 1 into a 4 to 2, we could multiply by 2. To turn a 4 to 2 into 6 to 3, that one's not as obvious. We could multiply by 1.5, but we could also go from this 2 to 1 to 6 to 3 by multiplying by 3. Okay? So again, the key here when we are trying to generate equivalent ratios is we need to always multiply or divide the numbers by the same value. We are going to practice generating some equivalent ratios below. I've got 3 ratios written there: 4 to 10, 12 to 5, and 75 to 100. I want you to generate 2 equivalent ratios for each. If you want to try this on your own and then check your answer with your teacher or with the video, that's fine. If not, I'm going to go ahead and start generating these equivalent ratios. So starting with 4 to 10. First, I'm always going to check to see if they have any common factors or the same thing we can divide them by. I noticed right away that both 4 and 10 are even numbers, and all even numbers are divisible by 2. So to generate an equivalent ratio here, I can divide both of these numbers by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. And since I divided them both by the same number, 2 to 5 is an equivalent ratio. I need one more, so I'm going to again start thinking about this 4 to 10. Unfortunately, they do not have any other common factors or things we can divide them by, so now I need to think about multiplication. You can really multiply them by any number you want as long as you are using the same number to multiply both 4 and 10 by. Since you get to pick, I'm going to pick something easy. I'm going to multiply by 2 on both sides. 4 times 2 is 8. 10 times 2 is 20. And again, since I multiply them by the same number, 8 to 20 is an equivalent ratio. Moving to my example in the center, starting with 12 to 5. I'm going to start by trying to think, do they have any common factors? I would eventually figure out that no, I cannot divide them by the same number, so my only choices here are to use multiplication. Again, you can use any number you want as long as you multiply 12 and 5 by the same value. So I'm going to go with easy ones. I'm going to start with multiplying by 2 on both sides. 12 times 2 is 24. 5 times 2 is 10. This is an equivalent ratio because I multiply by the same number on both sides. I've already talked about how these cannot be divided by the same number. So to pick a second equivalent ratio, I just need to choose another number to multiply by. Make it easy on yourself. I know my 2's really well. I also know my 10's really well. So I'm going to multiply by 10 on both sides. 12 times 10 is 120. 5 times 10 is 50. This is also an equivalent ratio. In my last example, I have 75 to 100. And I'm going to start by thinking what I can divide them both by. I notice that they either end in 5 or 0, and any number that ends in a 5 or 0 is divisible by 5. So I'm going to divide by 5 on both sides. 75 divided by 5 gives me 15, and 100 divided by 5 gives me 20. Therefore, 15 to 20 is an equivalent ratio. Again, the key being that I'm dividing by the same number on both sides there. 75 to 100 have other factors or things we can divide by in common. Think of it like money. 75 cents and 100 cents, or a dollar. Those are both divisible by 25 if you think of like quarters. So I'm going to divide by 25 on both sides. 75 divided by 25 is 3. 100 divided by 25 is 4. 3 to 4 is an equivalent ratio. You could have also chosen to multiply to create an equivalent ratio there. Just remember you're multiplying both of those numbers by the same value. Moving to the back side of the page, we're going to talk about where equivalent ratios are helpful in real life. And where you will see them most often is when adjusting a recipe. When you want to make something later on down the line, if you want to adjust a recipe to serve a certain amount of people, you're going to have to use equivalent ratios. So the table below shows the ingredients in the recipe to make Rice Krispie treats. If you notice, there are some spots missing in that table that we're going to have to fill in using equivalent ratios. So I'm going to have to be scrolling up and down to do this, but go ahead and follow along with me. To fill in the rest of this table, we're going to follow these steps. So the first thing we're going to focus on is the information we know. We know the full recipe amount to make 24 Rice Krispie squares. That is the only row in the table where I know how much butter, how much cereal, and how much marshmallow to get 24 squares. We also know the total servings for 12 and 36, but we don't know how much ingredients we need for each of those. So first I want you to focus on if we want to make 12 squares. I want you to think about what we're going to have to do with each of those ingredient amounts to get 12 squares. First, I want you to think about the total ingredient or the total servings. We know how to make 24. I want to make 12. What you need to start considering is how can you turn a 24 into 12? The first thing you should notice is we are getting a smaller amount. We want to go smaller. Whenever we want to go smaller, you should be thinking division. What can you divide 24 by to get 12? Eventually, you should come to the conclusion that you need to divide by 2. What you've heard us say a million times, and you'll hear it a million more, is that whatever you do to one side, you have to do to the other. So if you are dividing your total serving of 24 by 2 to get our new serving of 12, we have to do that with each of our ingredient amounts. So I'm going to start with my ingredient of butter. Originally, I know I need 3 tablespoons of butter to make 24 servings, but to make 12, I'm going to have to divide by 2. So I'm going to set up long division. 2 can go into 3 one whole time, and when I subtract, I get 1 left over. As we talked about earlier in this year, we can use this division problem to make a mixed number. It goes in 1 whole time with 1 left over out of 2. Meaning, to make 12 Rice Krispie squares, I would need 1 1/2 tablespoons of butter. I'm going to go ahead and fill in my table knowing that information. And now I'm going to move on to my next ingredient, which is cereal. Originally, I needed 6 cups of cereal, but since I'm turning my total serving from 24 to 12, I'm going to divide by 2. 2 can go into 6 3 times with nothing left over. So when I go in to fill in my table above, I am going to need 3 cups of cereal to make 12 servings. Finally, I need to adjust my marshmallow amount. Originally, I needed 4 cups of marshmallow, but now that I'm changing my serving size, I need to divide by 2. 2 can go into 4 2 whole times with nothing left over. Therefore, to make 12 servings, I need 2 cups of marshmallows. We now have step 3 done. We followed through what we decided in step 2, and we filled in that top row of the table. What if we want to make 36 squares? We now have 2 rows in the table to work with. We can either use our top row, making 12 servings, or a middle row of making 24 servings. You need to think about what's going to be easiest to turn into a 36. So the first thing I want to point out is whether we go from 12 to 36 or 24 to 36, we're getting a bigger number or a larger amount, which means we're going to have to use multiplication. So you want to decide what's going to be easier to turn into a 36. Can you multiply 12 by something easy to get 36? Or can you multiply 24 by something easier? Eventually you'll figure out that we want to use this 12 because all we need to do is multiply by 3 to turn it into a 36. If we were to use 24, we would have to multiply by 1.5, which just isn't as easy. So now we're going to follow through, and since we are using our ingredient amounts for 12, we're going to multiply by 3 all the way through. So if you remember, I needed 1.5 cups of butter, but since I'm turning it into 36, I have to multiply by 3. We just practiced earlier this year multiplying with fractions. So the first thing I'm going to do is turn my mixed number into an improper fraction. So I'm going to do the bottom times the whole plus the top. 2 times 1 is 2, plus 1 is 3. My denominator stays the same. To turn a whole number into a fraction, I can always put it over 1. From there, I multiply straight across. 3 times 3 is 9. 2 times 1 is 2. I need to make 9 over 2 into a mixed number. So 2 can go into 9 4 whole times with 1 left over. That means to make 36 servings, I will need 4.5 cups of butter. So I'm going to go back up to my table. And in the column that it says butter, I'm going to put the answer 4.5. Next, I need to talk about the cups of cereal. For my row in the table of 12 servings, originally it called for 3 cups. But since I'm increasing it to 36 servings, I need to multiply by 3, just like I'm doing with the serving amount. 3 times 3 is 9, and that is now the cups of cereal I'm going to need to make 36 servings. Finally, I need to adjust the marshmallows. To serve 12, I needed 2 cups, but since I'm increasing it, I need to multiply by 3. And my new ingredient amount is 6 cups to serve 36 people. I have already followed through with step 5 down at the bottom. I followed through with what we decided in step 4, which was to multiply by 3, and I filled in that bottom row of the table. I now have the ingredient amounts to serve 12 squares, 24 squares, and 36 squares. Remember, if you have any questions about these notes, please ask your teacher, and go ahead and get this checked by your teacher so you can make sure you did it correctly.